Good morning and happy Labor Day to you. Today is Monday, September 3rd, and I thought I would record a short video since this is really the first full week of our course. As you can see to the right, there is the schedule. I still don't have lines around the table. I'm working on that. Looks like I'll have to modify the HTML code itself to make that happen. Anyway, so you should have finished week one, session one yesterday, and that means you should have taken part in the forum, should have looked at the introduction video, and submitted the homework that was due. I see that hasn't been done by most of you. I'll attribute that to it being a holiday weekend, getting familiar with the course. So you have a few more days to accomplish those items. But in any event, today starts the second week, which is the first full week, and will be covering Chapter 1. You've probably noticed in the WebCT course that I have included in the session for Chapter 2 notes that I took on the chapter, and I put them there for your review. As I say in the notes, they don't replace the textbook. You really do need to read the textbook because the homework assignments come from the textbook. So, I'm going to rearrange the desktop a minute, and I'm going to take you through just a very shortened version of the Chapter 1 slides to try to highlight some of the important points. Okay, looking now at Chapter 1, Security from the Ground Up. We'll see some basic principles of information security, which you should be learning from this course. The phrases are capitalized in the book. They're usually general rules and often followed by secure systems or examples in the book. One of the principles that's used throughout this course, and actually is a principle of security, is this idea of continuous improvement. That is, you identify the basic goals, measure your success, and then adjust your work to better achieve our goals. And it's continuous because it keeps on going. It's like problem solving in that way. Once you learn what the problem is, you fix it, see how well that fix is, and then you continue to look at it to see if you can make it better. Can you make systems perform better? Here we're concerned about making systems more secure. So it is a continuous process. There is a 6-phase process that we'll use throughout the course, and these are the 6 steps: identifying assets and the risks attached with them, establishing a security policy, and most likely that will be your major project for the course, is to build a security policy. Then you implement that policy, you monitor to see how well you're doing, recover from any attacks because they're bound to happen, document those, and then go back and re-identify your assets. One of the reasons that this continues is because systems changed. You may start out with 10 features and add 10 more, and every time you add features you possibly increase the risks of security to additional assets that you've added. So it has to be continuous. The idea is here in a picture. You have different terminology here, which we'll look at in a minute, but you have assets which are protected, and then vulnerabilities are ways of getting at those. You put some defense or safeguard or countermeasure, things like firewalls or whatnot, that surround the assets to try to protect them and their vulnerabilities. And then, of course, you have the person who's trying to break in. So assets are protected by a boundary. It could be a hard boundary or a soft boundary. Typically it's both. And openings in the boundary are vulnerabilities. A room with assets in it that doesn't have a door or any other way in is kind of useless. So there's always going to be vulnerabilities. And then the person who tries to attack system that is unsafe to use is known as a compromised system. And on a network, if you have an entire network controlled by a single attacker, a single machine perhaps, that's referred to as a botnet. And then these are the names of different types of attackers that you can look at. Here's some examples of security architectures and boundaries. And gives you some clues for how do you assess a boundary. Can a threat agent breach a wall? How do we control the doorways? Can you pass through a doorway? And how much do we trust those inside the boundary? It's been proven over time that most of the security risks come from inside the company, not from outside the company. Here's the idea of least privilege. You restrict what people may do to an asset. And so the example in the textbook is Bob's PC in his room. And he's fortunate enough to live in an expensive college, I guess, so he has a suite surrounding his room. So there is a vulnerability and access to his room. There's another one that gets into the suite. And then presumably there's some protection at the door to control who is allowed to come in to the doors. And so the security gets tighter and tighter as you get closer and closer to the asset. Another principle is this idea of defense in depth by providing layers of defense. As we saw in the previous example, there are 3 boundaries that have to be crossed before you can get to the asset. CIA properties, these will appear throughout the course too. It's good to learn them now. The confidentiality. How do we keep information secret? Of course, things that might come to mind now are encryption or authentication with passwords or whatnot, maybe even digital signatures. And then integrity. Integrity means the data doesn't change. So there's no forgery, subversion, masquerade, attacks. And then finally, availability. You have to keep your systems available in operation and avoid what are known as denial of service attacks, where if an outside threat is unable to get to the asset itself to make a change or to steal it, they try to make it impossible for other people who have a legitimate need to access those assets. 5 recognized services. The first 3 are the same as CIA. Then we add authentication. Who are you, and are you who you say you are? Examples here would be passwords or some kind of token like a secure ID card, or even biometrics, thumb scanners or eye scanners. And then non-repudiation, which you may not have heard of before, services to reliably indicate the source and the receipt of a particular message. In other words, this guarantees that you did receive the message. Somehow it's marked as been received, and so you can't deny that you did receive the service. Here are some examples of general attacks. You can read through those. We again talk about asset identification and prioritizing the risks in the way of deciding what it is that has to be protected. The prioritization is important because not all attacks will cause equal damage, and not all are as likely. Okay, there's a couple other processes used. Octave approach, NIST recommendation, which is used for government agencies, and there's a couple pages on those in the book. The Octave uses a 3-phase, which is basically just a recasting of the 6-phase steps that we talked about earlier. NIST expands it up to 9 phases. Naturally, it's for the government, so they would make it a little bit more complex. And then finally, we turn to the idea of ethics. There are ethical issues in security analysis. For instance, is the search damaging, or is it even illegal? And if a vulnerability is found, what do you do with it? If you publicize it, you may actually be making the system more vulnerable. We recently, a big example of this was they discovered how to modify the H1N1 virus to make it communicable in the air. And once that research was discovered, there was a, do we make that kind of thing public? Because, of course, the risk is other people will develop that particular mutation of that strain. And, of course, keeping it secret means that other people won't have a chance to develop solutions. So there's always this balance that has to be maintained. Okay, that's pretty much it. So this is the first full week. Again, you should read the textbook material, read the notes that I have published on the session 2 in the web study course. Hopefully you listen to this video recording. It's not quite as long as the first one. I'm trying to get better at it and not make them quite as long. Finally, then you'll have the homework that you should do and turn in, and you will have a quiz. WebCT will call it an exam, but it's basically going to be 10 questions. You'll be timed, have about 20 minutes, I think, to answer the questions, and we'll have one of those for every chapter, which will help you prepare for the midterm and the final. Again, happy Labor Day, I should say. Don't eat too much, and see you online.